Welcome to our 13th session on integration. And there we go. Just let me know if you can't see my screen in a second. Should be up now. I am Ashley from Miss IB Maths, and I am an IB tutor and examiner and teacher. So if you have any questions at all, please feel free to direct them at my Instagram at Miss IB Maths. I'm doing this collaboration with Exam Dojo for these bootcamp sessions. I am so glad to see the comment. You are so welcome. I'm glad it's helping. This session will be on integration. So this is relevant for both AA and AI courses. But any of the questions that are, for AISL, whenever we do the integration in AA, you'll often have to do it yourself manually. But for AISL and HL, you can just use a calculator to do those integrations. So when it comes to that, I will tell you where the courses separate, but this is relevant for all courses. So let's have a look at what we have in our formula booklet. So for AISL, we are given the general formula for integration, the power function. We also have the area between a curve and the x-axis. We have some standard integrals, so these are very useful. If you have a function of 1 over x, then we have ln absolute value of x, very important to have those absolute value signs. Plus c every time that we're doing an indefinite integral, i.e. we don't have our boundaries. We need to make sure we're adding a plus c. For sine x, it's minus cos x. And for cos x, it's positive sine x. So just to keep in mind, these are the opposite of differentiation. We have the other way around for differentiation. So cos x is minus sine x and the other way around. And e of x, very nice and easy. It's just e of x. But these are for the very standard basic functions when it's just to the power of x. But when we start to have a linear function in the place of x, then we do one extra step, but we'll go through that as well. Then if we want the area, the total area between a curve and the x-axis, we need to do the absolute value. And we will talk about that more later. So that's for AA. For AI, in SL, you have just these two. So you won't be doing those linear functions. It'll be just very standard. You don't have to know the integrals for sine x, cos x, or any of those because you're going to do it all with your calculator. And the one extra thing is that in AISL, you have the trapezoidal rule, which is where you will be given a table of values, like you have your x values and your y values for a curve that's been divided into, let's say it looks like that. It's been divided into sections and you will use this rule. If you need any help with that, I'm not going to cover that today, but feel free to reach out at Miss IB Maths and I can maybe do a little video for you if you want. I'm happy to do that. If you also want extra sessions, private sessions, feel free to have a look on my website. So that's what we have for AI, not too much in AI because most of it is calculator based. All right, so our general rules, let's just have a look at these first. So this is for AISL and we'll just AI, and this is going to be just AA. So let me just write that there because you'll need to know how to do this without a calculator. But again, if you get this in AI, you will just use your calculator. So let's say that I have a function of x to the power of 4 dx. Then when I am going to integrate this, what I do is I take that power and I add 1 to it. So the opposite of differentiation. I add 1 to the power and I divide by that new power. And I add a little plus c. So sometimes you can see this written like that, 1 over 5, x to the power of 5. It's the same thing. And you can write any of these. They're both just as simplified as the other. So there's no wrong answer if you do that or if you do that, same thing. If I don't just have x to the power of 4, if I have a linear function inside, what I'm going to do is I'm going to take that function 2x plus 1. I'm going to raise the power to the power of 5. I'm going to divide by that new power. So very similar to that, but the extra step is that I also have to divide by this coefficient here of the x, because it's a linear function. Because if you can imagine, if I differentiate this 2x plus 1, I'll get 2. So I also have to divide by 2 here, whatever that number is. So my final, sorry, that's probably covered by my video. So let me just move that up and across. I'll have 2x plus 1 to the power of 5 divided by 10, 2 times 5. So that's just what we have if we have a linear function. And we'll see how that affects our other functions as well. So our 1 over x function, nice and easy, it's just ln of the absolute value of x. And for this one, it's going to be, let me write the full integral, 1 over 3x plus 2. See how it's not just 1 over x, there's a linear function in there. So we're going to take 1 over a. So whatever that a is, again, the coefficient of my x. And I'm going to do 1 over 3 ln, and then the absolute value of that function in the denominator, and plus c. So there we have that extra step there. That's the only thing that we just need to remember to do. This is not in the formula booklet for AA, so it's really important that you remember that, that you have to do that extra step. Same thing for the e to the x function. If we just have the standard e to the x function, super easy. The integral is just e of x. But if we have a linear function hiding within it, so I'm doing a few of these just because I want to really draw your attention to these linear functions, we're going to have to take 1 over 3 because I'll highlight it again. Where is it? And then it's just the function plus c. There we go. And the same thing with sine and cos. So let's take a look at those. So if we have to integrate sine 3x, that is sine 3x dx. Let me just put that in brackets. Then we're taking, so that number is 3. So if we differentiate that, it's 1 over 3. And then the integral of sine x is minus cos x. So it's going to be minus cos 3x plus c. And we can simplify that to minus a third cos 3x plus c. Hope I'm not covering that. And then for cos 2x minus 1, similar thing. We're just going to divide by that number, that 2. And then for cos x, it's just sine x. So sine 2x minus 1 plus c. So just so that you see that in all the different capacities, if you see the linear function in there, which is going to come up quite often, they're most likely not going to just ask for a cos x integral. It'll be cos with a linear function in it. Just remember to do that, to divide by that coefficient of x. All right, another thing that you might get asked to do is integration by substitution. So we are going to have to substitute something to rearrange. So we've got to choose a u function, like our inner function that we see. Then we differentiate that. So even though we're integrating, we're actually going to have to differentiate that inner function, that u function, substitute it back, and then integrate. And then substitute back again. So if that made no sense at all, no worries. Let's do an example. So we have 4x sine x squared. In SL, you are not going to be able to do integration by parts, which is what you would usually do with that in an HL course. But you can do substitution with this, because if I have this being my inner function, when I differentiate that, I'm going to get 2x, which is going to cancel with this x over here. So I want to get rid of that x and just have my function here. So let me do it in green on the side, my substitution. So very important to say what you're doing. I'm going to say let u equal whatever is in that inner function. See, what's in there is my inner function. So I'm going to take that to the side. I'm going to let that be u. So you kind of have to look out for what this will differentiate to see if it can cancel with something here. And then I'm going to take du by dx because I have u as my output and x as my input. So my function of u with respect to x. And then I get 2x. But now that I'm doing this in terms of u, let me just write that all together now. Oh, not that one. I want that one. 4x, nothing there. And I've taken sine of, instead of x squared, I'm going to write u. I'm now integrating with respect to u, not dx. So I need to rearrange this. So I'm going to rearrange this to be in terms of dx. So that will be du divided by 2x. So what I've done there is I've just multiplied dx on that side and divided by 2x, so it goes on that side. And the quick thing is I've just switched those over. So my dx is now du divided by 2x. I may have done that a little too quickly, so let me just take it up here and show you in case that made no sense. So I have du by dx is 2x, and now I want to get dx on its own. So in order to get dx on its own, I'm going to multiply by it on the other side. And then I still want to get dx on its own, so I've got to divide by 2x on this side. So I get du divided by 2x equals dx. So now I've got dx on its own. So in place of dx, I'm going to write this du by 2x. So let me write that there. Du divided by 2x. So I've just switched my dx to my du. This is a very important step. That puts that in the denominator. So now I can cancel out my x's, which is what I wanted to do. So now I just have a function that is sine u du. Let's simplify that a bit. So I have 4 divided by 2, which is 2. So I'm going to remove that 2 outside. I'm allowed to do that if it's a constant term. And inside, I'm left with sine u du. So what that did for me is I've now turned this into a very basic function that I can integrate. So I have 2, and the integral of sine u was minus cos u plus c. And lastly, I can't have it in terms of u. I need to have it in terms of x. So I'm going to put the minus with the 2 over there. I'm going to substitute my u, which was x squared, back in. Cos x squared plus c. And now I have integrated it. So that's a substitution thing that we can often get asked. Again, if you were in AISL, you're not going to get something like this because you don't know the sines integrals. You're not expected to know that. So if you had something, it would be a definite one with some numbers up here, and you could just go and put it on your calculator. All right, let's try another one by substitution. So I've got to make one of these equal to u, and I want one of them to cancel out with the other. So if I take u to be sine x, then my integral would be cos x, and then I could cancel out. But one of them, do you remember here how I had this 2x on the bottom? So then I could cancel with the thing on top. So I want to cancel with the sine x on top. So I'm going to let u be cos x. And if you didn't know which one to do, you would see that it's not going to cancel out and work. So it must be the other one. So don't worry if you don't see it. You can try both and then see that one is not going to lead you anywhere, and then just come back and do the other one. So let u equals cos x, then du by dx equals sine x, because the integral of cos x is sine x. And then I rearrange. So I have my du equals sine x dx. So I want to get dx on its own, and I'm going to divide by sine x. So I'm going to get du divided by sine x equals dx. Okay, so let me write my integral. Again, I'll change colors just to, in fact, I should do that on the other side just to keep with the same form that I was using. All right, so I've done all of that working on the side. So now I have my integral sine x over cos x, just writing it so we can see what we're working with. And now I'm going to do my substitutions. I still have sine x. I've substituted cos x for u, so I'm going to write u. And then instead of dx, I'm going to write my new dx, which is du over sine x. And now you can see one's in the top, one's in the bottom, so I can cancel them out. So that's what I wanted. Now I have a very basic 1 over u du. And do you remember what that function was? If we had 1 over u, can flash back to my formula booklet for a second. Always have this open next to you. It just helps you to be able to recognize things. See, this one over here. 1 over x dx gives us ln of absolute value x plus c. So let's go back. Where were we? No, not that one. Here we go. So that is going to be ln of my absolute value of u plus c. But I can't leave it in terms of u. I have to substitute back my u, which was cos x. There we go. And we've integrated. Okay, so those were what we called indefinite integrals, when we don't have numbers on the top, like the boundaries. So if I have like this, f of x dx, then I've just got to evaluate it. So that would be, we say, an indefinite integral. Indefinite. And if I have the numbers on the top, like 0 to 2 f of x, I'm finding a value, a number. This is finding a general function, like we've been doing. This, when I have the values, is finding a number, an area under the curve. I don't know, say 5. And this is called a definite integral. So here we're evaluating a definite integral, which means we're trying to find the area under the curve. So what we're going to go ahead and do is we're just going to work this out. We're going to integrate it, but let's multiply it out. That's going to make it easier to do. So we're going to have 3x cubed, because that's 3x times x squared, and 3x times minus 2 gives us minus 6x. So just simplifying it a bit before we work on it. You can put it in brackets if it's being a bit confusing. Okay, now let's go ahead and integrate. So I put my brackets on for my integral so that I can put my numbers on top so I don't lose them, because we're going to integrate so we don't keep the integral. So remember, we add 1 to the power, so 3x to the power of 4, and we divide by that new power. Same here, I'm going to add 1 to my power, so it's going to be 2, and I divide by my new power. And I'm going to write just on the ends of the brackets there, those boundaries that I have from 2 to 4. So this is a way of keeping with that to show, and it also helps you remember that you're not finished yet. So now we need to substitute 4 and 2. So we're going to take this whole bracket and substitute x equals 4, and we're going to subtract it by our law of calculus and do it with 2. So it's a little bit laborious, but let's go for it. 3, 4 to the power 4 over 4 minus 6. We're still going with 4. So all we've done is substitute 4 for this first bracket in both places, and we're going to subtract it and then do the same, but with 2. So 2 to the power of 4 minus 6. Looks a bit crazy, but we'll evaluate it and simplify it. Divided by 2. All right, I just double check because there's a lot of 2s and 4s. I had 4 in there, good, and I had 2 in there, good. And the main thing is that we're subtracting these with the x equals 4 and the x equals 2. So let's go and simplify that. Well, I have 4 to the power of 4 here and divided by 4. So that's going to leave me with 3 times 4 to the power of 3. And I'm just going to be super lazy. I was doing that one for later. I've already forgotten what I needed. 3 times 4 to the power of 3. Is 192. I just cancelled one of the 4s there. Let's keep my brackets actually. 4, so this is 6 divided by 2 is 3. 3 times 16. So we have 30 and 18, so 48. And the next one, 2 to the power 4 is 16. 16 divided by 4 is 4, so 3 times 4 is 12. That's 3 times 4 is 12. That's nice. 12 minus 12 is 0, so we're just minusing 0. So we have 192 minus 48. And that would be our area under the curve. So if we can imagine that we have those functions there, and that's sort of our area, we're finding that area under the curve. That's the value that that's giving us between, well, it's not quite accurate because it's between 2 and 4, so it's more like this. Our curve is going like that, and we want the area between 2 and 4. So we're finding that area. That's what that value is giving us. So anytime you have the indefinite integral, then you just have to go and substitute them and subtract them. If you're in AISL, you can just put that on the calculator, which is super nice. All right, sometimes they'll ask you to find the total area. So before we were just finding the area between the curve, but if they want the total area, that means we need to take the absolute value of the area. So if you can see here, this is a negative area. It's under the x-axis. So that's going to give me a negative area, something like, I don't know, minus 20. And this is going to give me an area of, say, 5. So if I want the area, and I just integrate the function, let's say f of x dx from a to b, if I just take it like that, then I'm going to do minus 20 plus 5. So that's going to give me minus 15. So the area it gives me is negative, which is fine. That's allowed. We can have negative area when we're doing a function like this. But if they want total area, then you have to do the absolute value of that area. So let's say total area is then from a to b, the absolute value of that. So then we'll take the absolute value of minus 20 plus 5, which gives us 25. And that's very different areas. So that's giving me the total area. If I absolute value that, then I'm not losing anything when I subtract. So just watch out for that. So we can do an example here. Find the total area enclosed by this graph and the x-axis. So let's draw a little diagram so we can see what's happening here. Let's see, I need to find my x-intercepts to see where we are going to integrate from. So if we differentiate this, if we factorize, we're going to get minus 5 and minus 1. So x equals 5 and x equals 1. So that's where our limits are. So let's say that's something like there and there. We're going through 5 on the y-axis, so it's going to be something like that. Ooh. So at these 2 points, this is the area enclosed between this graph and the x-axis. And can you see that's a negative area? But I want the total area. So if I want the total area, that means that I need to take the absolute value of this because it's under the graph. So it's going from 1 until 5. So let me write that as an integral. So I want the absolute value of x squared minus 6x plus 5, absolute valued dx. And I'm going from 1 until 5. From 1 until 5. So checking no questions. And this then I would evaluate. So I can do my 1 till 5. I can, in fact, go straight into it. To integrate it. So we're going to have x3 over 3. Remember, I want my nice brackets. Minus 6x squared over 2 plus 5x. We just add on an x. 5 and 1. I don't need to say plus c when I'm doing definite integrals. If you have those, you don't need to do plus c. So only if you're doing a general function. And then I would substitute 5 into each of these x's, and I would subtract it and substitute 1 into each of these, just like we did before. But in the interest of saving time, I did it ahead of time. Over here, you can see we have x squared minus 6x plus 5 from 1 till 5. And this was not absolute valued. So I just wanted to show you that we get a negative area. But because we want the total area, we're going to absolute value that. So then it was, well, let me just write it. So we're negative 10.6666666 absolute valued. So that's going to give us positive 10.67. And there we go. We should do 3 significant figures. Let's get into good habit of that. So 10.7. And that's the area under the curve. And because they said total area, we've got positive. If anything doesn't make sense, just let me know. All right, so that was the area that was enclosed between a graph and the x-axis. Sometimes they will ask us to find the area between two curves. So where they intersect, we need to find out, and then we're going to subtract the one curve from the other to get the area in between. So if we have two curves that look like this, then we're just finding this area here. Sometimes they can intersect and have more than one area. So this curve here, where we have that and then this. So that would be our area 1 and that would be our area 2. And you can see this graph is on top of this one at this point. So between whatever value is here, let's say 2 and 5 and 7. Between 2 and 5, we have the blue graph on top of the red graph. So we're going to have to subtract f of x minus g of x. That integral we're going to have to find from 2 till 5, because that graph is on top. But for this area, the red graph is on top. So we'll have to do g of x minus f of x. And that's from the interval 5 until 7. And then we just add those areas. So just important to sketch it if you can, or get your calculator to sketch it if you're allowed, just to be able to see that sometimes we're going to have to do them separately because this one is on top here, but this one's on top here. And it's always the top function minus the bottom function, which makes sense. So let's see that in a, well, no, this is not an example, but let's do an example. So I need to find the area enclosed between the graph of y equals x minus 2. That's my blue linear function. I'll just do it under in blue. And between my y equals x squared, my red function. So which function is on top for that area? We want to find this area. Which function is on top? Well, it's the blue one. And where you can see that this function is like on top here, but we're talking about the area. So the blue is on the top and the red is on the bottom for the area that we're looking at. If we're looking at this area, then yes, it would be different. Then the red one's on top, but we're speaking specifically about the area. So let me first find, it's shown here, but let's do it anyway. I need to find these values. So you always need to start with finding where these two graphs intersect. So I'm going to say, I'm going to take my first graph, x plus 2 equals to x squared, my other graph, this one equals this one. That's always how you find your intersection points. So we want to find these values, our lower and upper bounds, basically, for our integral, where it goes from there to there. So I can see this is a quadratic. Let's move everything over to one side and factorize or quadratic formula, whichever you're more comfortable with. And that's going to be minus 2 plus 1. So x equals 2 and x equals minus 1. So now I know that my integral is going from minus 1, always the lower one, to 2 to find that. So that there is minus 1 and that over there is 2. So once I've found my limits where I'm going from, I can set up my integral. So we're going from minus 1 to 2. And then we're doing our top graph, the blue one, x plus 2. And I'm going to subtract it from my lower graph, the red one, x squared. put that one in brackets as well, just so it's super clear. My blue graph minus my red graph. So now I've set up my integral. If you are in AISL, you can go and put this on a calculator. You can go here, you can press this button. There's my integral. And fill in my values. If this is paper 2 for AA, you can also go and put it on here. There's nothing wrong with that. We're going from -1 to 2 of our function x plus 2 minus x squared. Just double check that that's correct, no minuses. And I'm integrating with respect to x. And that gives me 4.5. So you could do, sorry, don't want to be too quick. If you are in AA in paper 2, you just do that. And if you're AISL, you can immediately do that every single time. But otherwise, you'd have to integrate it. So let's go ahead and integrate it. Why not? Don't forget our big brackets. So x is going to be x squared over 2. 2 is going to get an x. This is going to be minus x3 over 3 with my limits over there. And now I need to substitute for 2 and then -1. So 2 squared over 2 plus 2 times 2 minus 2 to the power of 3 over 3. So that was just for x equals 2 minus, and now we're going to substitute for -1. And let's be very careful with brackets here because it's a -1. There's a lot of squares going on. 2 minus 1 minus -1 to the power of 3. Just when in doubt, use brackets. There we go. So I've taken with x equals 2 and with -1 and subtracted them. And now what do we get? So that's just 2 plus 4 minus 8 over 3 minus 1 over 2. And that becomes -2, but with that minus there, it makes it +2. And this is, there's a lot of minuses. That's -1. So that -1 and that minus make it +1, but that minus makes it a -1. So there we go. And then we can solve for that. So do we do that? Yes, why not? Let me not be lazy with my adding. So 2 plus 4 plus 2 gives us 8. I see -8 over 3 minus 1 over 3. That gives me -9 over 3. Minus a half. I'm just grouping things that are easier. 9 over 3 is just 3. So 8 minus 3 is 5. Minus a half is 4.5. All right. And that is true. That's exactly what we got there. So we are correct. So yeah, quite a bit of algebra in there if you are not having your calculator, but there we go. The main message is just figure out, firstly, where the two graphs intersect, and then which graph is on top to subtract it from your other graph. And there you have your integral to solve. Okay, so let's try one where we have two different areas. So I've got the graph here already drawn, and we can see there's two areas. So I'm going to split it into two. So I need to take, let's do my colors. Let's call this my area 1, and let's call this my area 2. So they're going to have different intervals, and you can see this graph is on top of this one, and here it's the other way around. So let me say this, how should we do it? Let's call that one f of x, and let's call this one g of x. Just so we know what we're doing. So first step is to find where they intersect. So set them equal to each other. We can see it here on the graph, but let's pretend that we don't know that. So set them equal to each other. I'm going to move 1x over. It's important not to divide by x on both sides. You can do that and you'll get two solutions, but then you also need to recognize that 0 is a solution here. But if you factorize, you'll be able to get that. So let me factorize x out. So I have x squared minus 1 equals 0. And then x squared minus 1 is x minus 1, x plus 1 equals 0. So then you can see I really have 3 solutions here. Whereas if you do, let me show you the dividing method that I know a lot of students do. If we just divide by x, and you say divide by x, you get x squared equals 1, and then you square root, and you might just even say 1, but hopefully you say positive negative 1, but then you don't get that solution of 0. You'd have to recognize here that if x is 0, you get 0 equals 0. But if you factorize, you get all those solutions. So x equals 0 here, here x equals 1, and here x equals minus 1. So those are those 3 points over here. So let me write them in, let's go in, no, which color haven't I used? Let's get a new color. Let's do something to not confuse anyone, orange. So that would be our minus 1, this would be our 0, and this would be our 1. So for this integral, we're going to have for our area 1, it's going to be the integral from minus 1 to 0. And we're going to take the blue graph, the one on top, that's the x cubed, minus the x. So that's for my area 1. And then for my area 2, I'm going to have the integral from 0 to 1. And now my red graph is on top, so it's x minus x cubed. Don't forget a little dx on everything. So you can see the differences there. The boundaries or limits are different, and the order is different because at different points, a different graph is on top. So then we would evaluate those 2 areas, and then we would, sorry, I'm covering that. Let me do like that, and hopefully you can see. So now we just need to evaluate those integrals. So we would say, well, the integral is then x4 over 4 minus x2 over 2 from minus 1 to 0. And I would figure out what that was. And for this one, it's x, we add 1s over 2 minus x4 over 4, but from 0 to 1, and get a value. And then once you have those 2 values, you just add them together. So the area of the one plus the area of the other gives you your total area. So I'm not going to do these integrals again because I have done them a few times. So hopefully, covering it again, hopefully that makes sense with what you have to do for these kind of questions. And this is an AI-SL as well. You also have to be able to show that you understand the 2 different areas. Even if you can just put the final calculations on your calculator, you do need to be able to distinguish. All right. I hope I wasn't covering that too much. Okay, let's try some exam style questions. So this is from a paper 1. Now, if you are AI-SL, just a reminder that you can use your calculator for this. In fact, you wouldn't get this kind of question because we don't have any limits. But what you might get, so this is still important to you, you won't get such a complicated function. You'd get a simpler one that you could answer, just like the ones we did at the beginning. But this boundary condition is important, that f0 equals 5. So that's giving you a clue for finding C. This is we call this an initial condition. So this is going to help us find our value of C. It's like a coordinate, an X and a Y value that we can substitute to help us find another missing value. So this part is relevant for you in AI-SL. You need to know this as well. But the integrals is a bit more challenging than you would have. So we need to integrate this function. We're given the derivative function, and we need to find the original function, f of x. So that's always your hint. If you're given a derivative and you need to go backwards to find f of x, that means that it's integration. So 2x squared plus 1. Now, think about it. There's quite a lot going on in this function. What rule could we use? Can you see anything? Look for, if you find the derivative of something, it looks like it could cancel with something else. So this would be where we're using u substitution. So we're going to have to substitute a u, and usually it's an inner function. So when you see a square root, when you see brackets like 2x squared plus 1 to the power of 5 or something, then this is what we would have as our u, our inner function. Or if you have root 2x squared, these are all things you need to look out for that are indicators of u substitution. When you have that like inner function, a function inside a function. Another thing could be inside the sine function, like we had earlier. Then you can see there's that inner function inside the sine function. What other ones do we have? Yeah, I can't think of any at the moment. But all these ones where you have a function inside a function is a hint that we're using u substitution. And you're going to make the u the 2x squared plus 1. You're not going to include the root. The root is not part of the inner function. The root, if you include the root as your u, is going to mess you up. So u equals, let me do it in green so I keep with my side working. My u is just what's inside. So not the root. Okay, let me just take these away. Okay, so now I need to do du by dx. That gives me 4x. Remember, we're differentiating here. And I need to make dx my subject. So I'm going to have dx equals du divided by 4x, which is great because now I have that 4x in the denominator that's going to cancel out with my x over here. So let's write that all together. Nope. So that gives me 8x over, don't forget my root, and now that is u. Don't worry about that root. And instead of dx, I'm going to write du by 4x. And now I can simplify. So that x cancels out with that x. 8 divided by 4 just gives me 2. And what I can do is remove that 2 because it's a constant outside. So I am left with 1 over root u du. And this is fine. This is just a power function because what is root u? Root u is the same as saying u to the power of a half, and that's fine. We can do that. We add 1, divide by the new power. And if I have 1 over root u, that is the same as saying u to the power of minus a half, because when we bring it up, it becomes minus. So I'm going to write that in. So that will be u to the power of minus a half du. So that gives me, now I can integrate. Minus a half plus a half is going to give me positive a half. And then I've got to divide by my new power, which is a half. And plus c. And then let's just simplify that. So 2 divided by a half is actually 2 times 2. So that's going to actually give me 4. 4u a half plus c. And what was my u? U was 2x squared plus 1. So 4. Well, let me not do too many steps in one, just in case. U was 2x squared plus 1 to the power of a half plus c. You could leave it like that, but to the power of a half means a root. So 4 root 2x squared plus 1 plus c. All right. And maybe I'm going to move that up. I'm not finished yet because I need to find c. That's why they gave me an initial condition. So I need to use this information that they gave me here to find my c value. So they've given me, and let me write actually f of x equals 5 and x equals 0. So I'm going to substitute that in. Maybe I'll use a different color. So 5 equals 4 root 2. And in place of x, I'm putting 0. 0 squared plus 1 plus c. So 5 equals, well, 2 times 0 is just 0 plus 1. Root 1 is just 1. So that just leaves me with 4 plus c. So c equals 1. And now I need to write my whole function. So f of x equals 4 2x squared plus 1 plus my c, which I figured out was 1. Let's put a fancy box around it so we know we're absolutely done. There we go. That is our final function. That's our answer. In our mark scheme, an attempt to integrate, making your u substitution, just quite a few method marks there. Yeah, nothing too interesting or crazy there. Okay, a similar kind of question. We're given the derivative of g of x, and we need to integrate to find g of x. So just the different kind of function here. Let's write it as an integral. So don't forget to always write it officially as an integral. Look out here for, this is just a cos x function. So that's nice and easy. That's just going to be sine x. And this one is going to have, remember from the beginning, e to the 2x. Let's just go and look at that again. Where were we? Where was my e function? Here. So because we have that 2x hiding up there, it becomes a function like this. So we're going to need to divide by 2. And then we had a cos x, which is going to become sine x. Don't forget to check that because you can often forget which is positive and which is negative. So where are we? Here we go. So we're writing it like that, dx. And now let's integrate. So we have, in fact, we don't need our brackets. Ooh. So cos x became sine x. That was nice of them. This is paper 1, by the way, so no calculator. And then for e to the 2x, we had to do divided by 2, that coefficient there. And then the function is just itself, and plus c. How lovely and easy. So that was g of x. And then finally, again, we have been given a boundary condition or initial condition. So we need to substitute 7 equals sine of 0. Love it when they give us 0. Makes everything much easier. E to the 0 plus c. What's sine of 0? 0. That just becomes 1. So plus a half plus c. So 7 minus a half equals c. So c equals 6.5. And don't forget, once you found your c, you're not done. You need to write the function with your newly found c. So sine x plus a half e to the 2x plus 6.5. There we go. Any questions? No. Hopefully you can see that. And nothing crazy in the mark scheme there. Just a lot of method marks. That was a good 5 marks. If you get a question like that, that's super nice. All right, anyone feel like they're scared when they see questions like this? Don't be, just take some time to get to know the situation. All graphs look scary when you first see them, but take some time to just have a look what's really happening before I even read my questions. I know a lot of students, they see this, they go, oh my gosh, I'll figure out what I need to know later. And they say, write down the value of c, and they start with that. And it's like, well, what is c? Where does c come from? So let's ignore that even. I'm taking it off the screen, and we're just gonna familiarize ourselves. Okay, so there is a line with an equation, y equals minus 3x plus 9. That must be my linear function. So that one over there is my linear function, okay? I'm going to call that f of x, just so I can talk about it. It intersects at these 2 points with my other graph, so that's nice. That's already a hint that they're giving us our limits, and we're probably going to have to find this area between the curves. No problem there. They've already given us the limits. We're going from 0 to 3. How nice of them. We don't even have to calculate it. The exam questions often give you more than you think. A parabola, obviously we see our parabola upside down, so make sure that you're getting a negative value there, is y equals ax squared plus c. So that's going to be our g of x function. Ax squared plus c. Well, c is just your y-intercept. So on this graph, on this parabola, what is your y-intercept? Well, it's 9. We can see it's already given there. We don't even have to calculate that. So I can already write in, it's probably going to be a question later, but that's plus 9. A, I don't know what that is, but I have some coordinates here that can help me find A. All right, so already we've looked at that, and maybe it's not as scary as it might have looked before when we first saw it. So they say write down the value of C. When they say write down, you just need to put the number. You don't even need to show working. You don't need to show any explanation. Write down is a lovely command term that just means put it there. 1 mark. So don't think too much about it. Usually these 1 mark questions that are write down, it's given and you don't have to do any calculations. So the value of C, no, didn't mean that one. Didn't mean that one either. What is going on? Just having a bit of a moment. Okay, C equals 9, right? We had that there. That was just the y-intercept. Now the value of A, and that's 2 marks. So we're going to have to do some working. So let me write my new function. Y equals ax squared, and we know that C is 9. So I have 3 unknowns, but luckily they've given me a coordinate here. I'm not going to use that one because that's already used with that one. So I'm going to use 3 and 0. So 0 equals A. My x is now 3 squared plus 9. So I've just used the coordinate there of 3, 0 for my x and my y because I know it's on that quadratic line, so that's fine. Now let's simplify. That's 9a plus 9. So then I get 9a equals minus 9. So a equals minus 1, which negative, that makes sense because it's an upside down parabola. So let me just, well, I can write that there. A equals minus 1, but I need to show this as well. A. So make sure you do that full working to get those 2 marks. Okay, so now I have my full graph. So g of x is equal to minus 1, so minus x squared plus 9. And my f of x, we have minus 3x plus 9. Now let's see, what's the next question? Surprise, surprise, an area between the curves question. So we need to find the area of the shaded region. We need to find this here. So we need to set up an integral. We've already got our intersection points from 0 to 3. That's given in the question there. That's coordinate 3. So that's nice. So we can set up from 0 to 3. And which graph is on top? Our quadratic is on top for this section. So we're going to take the top function, the quadratic, minus x squared plus 9. Minus x squared plus 9. And we're going to subtract it from our lower graph, this line, our straight line here. And the equation of that was minus 3x plus 9. So that's right, minus, let me put it in blue, 3x plus 9. I'm writing it in brackets because we're minusing, so we really don't want to get caught out there. When in doubt, brackets. And then we've got our integral that we've got to solve to find the area between. So let's simplify this a little bit. We have minus x squared plus 9, and here we're going to get a minus 9. So that just plus 9 minus 9 is 0, and then minus 3x. That's a lot simpler. So this is our integral to solve. And this was a paper 1 question. So we need to do it ourselves. But if you're an AISL, this is the point where you would just put this on your calculator, you know, like this, and you'd get the answer. But if you're in a paper 1 of AA, we're going to have to do it ourselves. So we integrate it. And we're going from 0 to 3. And now we've got to substitute 3. So that's minus, I'm just going to write, because it's positive, 3 minus 3 to the power of 3 over 3 minus 3 squared over 2. And that was my first bracket when I substituted in 3, and I've got to substitute in 0. But when I put 0 into this, that's just going to make that 0, and that's going to make that 0. So just minusing 0. It's lovely when they give you between 0 and something. That saves a lot of time. Okay, let's simplify. So that would give us minus 27 over 3 minus 3 to the power of 2 is 9 times 3, so also 27 over 2. 27 divided by 3 is 9, and 27 divided by 2 is, well, half of 26, 13, so 13.5. Minus 9. No, do I have a negative wrong somewhere? Feel like I may have a negative that I shouldn't. Did I miss a negative somewhere? Oh, was it minus 3x minus 9? Yes, there's a minus there that I did not copy across correctly. So sorry, that should be minus, oh, no. Minus 3x minus 9. So that would make that positive 3x. And that would be positive, that would be positive. And so that's positive and positive. There we go. Just copied that wrong. Learn from my mistakes. So minus 9 plus 13.5 gives us 4.5. And there we go. How we finish the question, always check, find the area of the shaded region. Indeed, it is 4.5. So there we have an example of how some questions could ask. And see, it wasn't that scary, actually, in the end. It was not too bad. That was for a lovely 7 marks. Okay, so again, nothing crazy. Just make sure that if you are in an AI-SL exam, that you are writing down the integrations that you're doing. So even though you need to do it on your calculator, make sure you're setting up integrals, you're writing values, you're writing functions, whatever they are. I'm just making some up. Make sure that you're showing this, and then you're putting it on your calculator and giving your answer. So very important that you show that, even though it's mostly on your calculator. For AI-SL, that goes for a lot of things. And also for AA, you should show you're working, show more steps than you think you need to. Lots of method marks to be won. And don't forget to have your answer exact or to 3 significant figures. Okay, I think maybe I'll do one more. Just, I know it is 6, but why not? Just another way that the question might ask. Find the area enclosed by the curve. So I'm just going to draw a rough sketch of the curves, e to the x minus e to the x, and between minus 1 and 1. So let's say minus 1 is there. I don't know, let's say 1 is there. So we want the area between the curve between there and there. So that's this area. So when they say between these lines, x equals minus 1 and 1, that's another way of saying that your boundary is just going from minus 1 to 1. That's all. And then e of x is the top curve, and e to the minus e of x is our bottom curve. So we're doing this one minus this one. So e to the x minus e of x. So just subtracting those two graphs. And then we're going to get minus 1 to 1. Simplify that. That becomes positive. So we have 2 e of x's. And then this is a paper 1, so you're just going to have to simplify as much as you can without a calculator. So when we find the integral of this, we can actually move the 2 outside because it's a constant. and have e of x, which is just a simple function, e of x. So our answer there is 2e of x. And we're in a definite integral, so there's no plus c, but we do have our values. So that would be 2e to the 1 minus 2e to the minus 1. And, well, 2 we can keep outside. So that would just be e minus 1 over e. You could write it, you could leave it like that. That's also fine. That minus 1 makes it go down. Factor 2 out, but either of these are acceptable. And that's as far as you can solve it. You can't go any further than that in a paper 1 with no calculator. So that would be acceptable to leave it like that. So as you can see here, these are the different ways that you could have left that answer without a calculator. So how I did it, or the first way that I had, whichever one, they're not really more or less simplified than each other. Okay. Yeah, the mark schemes, there's nothing crazy. There's a lot of attempts to do something, attempt to set up an integral, attempt to substitute, subtract their integrals. So even if you have no idea what to do or you don't understand, just write what you think is happening, and it doesn't matter if it's wrong. You can so often get method marks for attempting. And again, that goes for all questions. Never leave anything blank. If you have blank answers, there's no marks. But if you have something, even if it doesn't make sense, and you kind of have an idea, but you're not sure, but you've done something, you can often get those attempt marks, which is better than nothing. And one other tip is that if you are unsure about something and you cross out, like you're doing your working, I don't know, 2x plus 1 equals 7, x equals 10, I don't know, and you're like, oh no, that's not right, and you scratch it out, you can't get any marks. But if you leave it and you're not going to come back to it, I see this so many times where, so many times where as an examiner, they haven't written anything else, and I look in their work and I see, oh my word, that would have been a mark, that would have been a mark. They just didn't realize it in the exam. So even if you think it's wrong, don't cross it out. If it's crossed out, I have, by IB law, I can't give marks for it. I'm not meant to look at it. I often look at it because I'm quite curious, like what they crossed out. But that's just probably one of the best things I can say. If you're not going to come back to it and try it again, don't cross it out. Rather leave it there. Let me get rid of that before someone thinks that I don't know how to solve two-step linear equations. Okay. I think, yeah, that's some exam tips. Like I said, always write the brackets, the big brackets, square brackets, so that you remember that you've got to substitute your boundaries. Be very careful with brackets. Use more brackets than you think you need. Definite integrals can be negative, just like we were saying. But if they want total area, you want to look for the keywords total area. That should not be negative. Total area is always the absolute value, remember. So if they haven't said total area and you're just finding a definite integral, that's fine. Negative's fine, but total area should be positive. And don't forget to write plus C. That gives you marks always to have that plus C. So don't forget that. All right, as usual, there are more exam tips, common mistakes, worked examples, tips, everything in Learn. So if you go to Learn on Exam Dojo, for every single topic, there are so many good notes that I just can't recommend enough to go through. And yeah, the homework assignments for this weekend, I will be uploading after this. All right, well done for sticking around, especially on a Sunday afternoon. I don't know if you have exams tomorrow, but I hope you're feeling good about them and feeling good about this week. It is almost at the end. You're so close to being done with IB forever. But hopefully something here was new to you and that you learned something. But yeah, does anyone have any questions? I'll give a couple of moments just in case anyone is typing anything. Feel free to ask anything. We have some more sessions coming up this week. Yeah, if you think of any questions that you want to ask, After this, feel free to go find me on Instagram. I also put exam tips and study tips and things like that there. So if you have any questions, feel free to DM me. Happy to answer. Oh, and the exam notes and these notes and exam past paper questions per each of the topics we've covered with the mark schemes are also in a big folder. And if you want that link to the folder, just DM me with your email address and I'll send it on to you. Okay, I don't think there are any questions, so I will end it there. No. Thank you so much for joining and good luck with everything that you are doing this week. Goodbye.